is hinged at A and D and is supported by a cable that passes through a ring at B and is attached to hooks at G and H. Knowing that the tension in the cable is 525 newtons, determine the moment about the diagonal AD of the force exerted on the frame by portion BH of the cable. So I've written out our tension that we're given, as well as what we need to find. And this equation right here that we have, the moment about an axis is equal to the unit vector pointing along that axis dotted with r cross f. Notice the difference from this equation right here. When the moment is equal to r cross f, we're given the moment as a vector. But when you dot it with its unit vector, it comes back to us as a scalar. And if you remember from problem number 2, we took the moment about A, the magnitude of the moment about A, by using the square root and squaring all of its entries. But that doesn't work for a moment about an axis. So this is a moment about a point right here for a scale for its magnitude, and this gives us the magnitude of the moment about an axis. All right, so let's begin our analysis. So specifically, the problem wants to know what the moment about the diagonal AD is, and it also wants to know from the force from the tension BH. So really, we know that there's a tension TBG, and there's tension here TBH, right? And there's also a force of P right here, but that's not what the problem is asking for. So it can seem kind of like a lot of information, but we can actually just erase TBG when we're solving this problem, and we can also ignore P. All right, so let's go and solve the problem. So we know, as we said before, MAD, so that's bad written MAD is equal to the unit vector pointing from A to D dotted with, and then it's important to note that we can choose any point along AD and we'll get the same moment value, but for ease of the problem, I recommend choosing point A or point D. So UAD, and then we want the direction vector pointing from A to B, crossed with TBH. All right, so that's the equation that we're going to be using for this problem. And we know that our UA of D is equal to 0.8 I minus 0.6 K. And we also know that R B is equal to 0.5 I. And if you notice, the unit vector is a unitless quantity, but our direction vector does have a unit of meters. So it's important to note. And then now, if we want to find the components of T, we need to find its unit vector pointing from B to H, and then multiply that with its magnitude. So the unit vector pointing from B to H is equal to 0.33 I plus 0.67 J minus 0.67K. Let me just double check that. Yeah. So we have our U V of H. We can multiply that to our tension and set it up in our cross product. And once we dot all of that together and do all the arithmetic, we'll get that the moment of A of D is equal to is equal to 44.6. Oh, sorry. That's from the last problem. Is equal to negative 105 Newton meters. And this negative sign means that the moment is not going clockwise, but is being produced, or sorry, not counterclockwise, but it is in the direction clockwise. All right. That was all of the homework. I hope that was of some help. I will be posting the solutions later, and best of luck.